An airplane is sighted at the same time by two ground observers who are 4 miles apart and both directly west of the airplane. They report the angles of elevation as 14 degrees and 22 degrees. How high is the airplane? So again, like we saw last week, we're going to read these problems first once, and then the second time we read through it, we're going to start labeling. Okay. An airplane is sighted at the same time. Airplane in the air. Sighted at the same time by two ground observers who are 4 miles apart and both west of the airplane. So these guys are 4 miles apart. So I'm going to draw that connection between the two of them. They are 4 miles apart. I will label that right away as 4. Might as well give them names. I'll give those points names anyway, A and B. And they both see the airplane at the same time. That's where triangle comes out of this. The next thing it tells us is that the angles of elevation are 14 and 22 degrees. Now, it is important that we put them in the right spot. In order to do that, we have to make sure we know what this word angle of elevation means. So an angle of elevation is the angle from a horizontal up to another point. So if you are standing in this spot B and looking up at the airplane, the angle of elevation is the angle between the horizontal line here, the dotted line that I drew, and the direct path to the airplane. That's the angle of elevation. So we've got two angles of elevation here. So I'll label them with two different markings. The smaller one is the one where I've marked angle A. So that has to be the 14-degree angle. The 22-degree angle is the angle of elevation from angle B. And notice how that 22-degree angle is not inside the triangle that I drew. Of course, we can figure out what angle is inside the triangle if we just subtract 22 degrees from 180. That means the obtuse angle B inside the triangle is 158 degrees. I'll call this point P for plane. Now, notice how we haven't marked off what the question is asking for yet. It said, how high is the airplane? I could find this length right here. Remember, we can use law of sines because we have an angle-side pair. And you might be thinking, wait a minute, no we don't. We see side P is 4. Angle A is 14 degrees. Angle B is 158 degrees. Looks like, wait, we don't have an angle side pair. But remember, when you have two angles in the triangle, you have the third also. If 158 and 14 degrees add up to 172, that means the last angle in there is only 8 degrees. So angle P is 8 degrees, and we do have the angle side pair of angle P and side P. But even if I did find this measurement using the law of sines, that wouldn't answer the question. The question asked for the height of the airplane. I want to know how high is that. Now, important to remember that height is perpendicular to the ground. So I'm looking for that height, and we're going to have to use two different steps here to find. So what we can do is find point A using the law of sines, and then we'll come back and use SOHCAHTOA to find side H. So I can say that A over the sine of 14 degrees is equal to P over the sine of angle P, which means that A is equal to 4 sine of 14 degrees over the sine of 8. And we can turn to Desmos for an approximation of that. Remember that Desmos is going to be in radian mode until I tell it otherwise. We've got to switch that to degrees. 4 sine of 14 divided by the sine of 8. And this distance is, A is 6.95 miles. So we'll label that on our chart. But remember that I don't really want to have to write down that in the calculator. So what I'm going to do is call this a. So that way I can use the name a whenever I need to in the calculator. And then to find h, my next step is to say that the sine of 22 degrees using SOHCAHTOA is equal to the opposite over the hypotenuse. And I apologize that I'm using a and h there. A stands for height in this case, not hypotenuse. I know that's a little bit tricky. And A stands for the side across from angle A, not the adjacent. So I do apologize for that. But then if I want to find h by itself, it is equal to a, which we do know. I'm calling it a so I don't have to write around the decimal. But I do know what a is. And so we can use Desmos to say that a times the sine of 22 degrees is the height of the airplane, 2.6 miles. And that would be the final answer.